Hello everyone. So in this particular session we will learn about the basics of turning moment diagrams and some problems on this particular unit. So coming to the turning moment diagram, so it is nothing but the diagram which is plotted by taking the crank angle on the x-axis and turning moment on the y-axis. So the obtained diagram is called as the turning moment diagram. We can also call it as crank effort diagram. So this diagram varies depending upon the type of the engine. So here you can see the turning moment diagram of a single cylinder double acting steam engine. So this is the turning moment diagram of a 4-stroke cycle internal combustion engine. As you all know, so there will be 4 processes: suction, compression, expansion and exhaust. So expansion is also called as the working stroke. So it is the positive loop, or we can say the work is developed in that particular process. So the turning moment diagram for a multi-cylinder engine will be like this. So here in this 16.3 diagram represents the multi-cylinder engine turning moment diagram. So there will be problems on turning moment diagram with respect to the multi-cylinder engine. So there will be calculations of maximum fluctuation of energies. So I will discuss this particular concept by taking example. So coming to the formulas you should remember. So you should remember the formula of coefficient of fluctuation of energy. So which is denoted with CE. So it is the ratio of maximum fluctuation of energy to the work done per cycle. So I will tell you all the formulas which you need to remember for your exam sake. So coming to the next formula, work done per cycle. So it is the most important formula you need to remember for this entire unit. So work done per cycle is equals to T mean into theta. So T mean is the mean torque multiplied by the crank angle theta. So crank angle depends upon the type of cycle or else type of engine. So as you can see in this particular page, so theta is equals to 2 pi in the case of 2-stroke engines and 4 pi in the case of 4-stroke internal combustion engines. So please remember this formula, work done per cycle is equals to T mean into theta. So coming to the other formula which has the relation between T mean and power. So T mean is equals to power into 60 by 2 pi n, whereas P is power and n is the rotational speed which is given in RPM. So another formula for work done per cycle is power into 60 by n, where small n represents the number of working strokes. So small n is equals to capital N. If he gives you that it is a 2-stroke internal combustion engine, then you need to take small n is equals to n. If he gives you the problem with respect to the 4-stroke engine, then you need to take small n is equals to n by 2. So please remember this formula also. So work done per cycle is equals to power into 60 by small n, and remember the formula for small n also. So coming to the flywheel, so we can describe the flywheel as a particular machine which is also called as the reservoir. So if there is any excess of energy, then it will absorb the energy. So if the energy is less or deficient, then it will supply the energy. So this is called as the reservoir. So it will control the speed variations by controlling the energies. So coming to the next formula which you need to remember, it is coefficient of fluctuation of speed denoted with CS. So CS is equals to N1 minus N2 by N. So N is the rotational speed in RPM. So N1, N2 are the maximum and minimum speeds. N is the mean speed. So the formula for mean speed is N1 plus N2 by 2. So CS can also be denoted in terms of speed, in terms of angular velocity and in terms of velocity. So as you can clearly see in this particular page, CS is equals to N1 minus N2 by N. if we substitute n is equals to n1 plus n2 by 2, so then the formula will become Cs is equals to 2 into n1 minus n2 by n1 plus n2. So we can write in terms of angular velocity, so omega 1 minus omega 2 by omega, and we can also write in the form of velocity, so v1 minus v2 by v. So mostly we will use the formula which is in terms of capital N, and moreover there is another formula for coefficient of steadiness which is denoted with small m, which is the reciprocal of coefficient of fluctuation of speed, so 1 by cs, so m is equals to 1 by cs. Please remember all these formulas. And coming to the flywheel concept, so let m is the mass of the flywheel which will be given in kgs, or if it is given in tons you need to convert it into kgs, and small k is the radius of gyration of the flywheel which is given in terms of meters. So capital I is the moment of inertia of the flywheel, so moment of inertia formula is mk square, so the units will be kg meter square. So please remember these formulas. So maximum fluctuation of energy delta E is equals to, in terms of kinetic energy, maximum kinetic energy minus minimum kinetic energy. So the final formula for delta E is I omega square omega 1 minus omega 2 by omega. It can also be written as I omega square Cs. Why? Because the Cs formula is omega 1 minus omega 2 by omega. So replacing that we got I omega square Cs. I is mk square. So I, in terms of, in place of I you substitute mk square. So it will be mk square omega square Cs or 2 ECS. So there is, please remember all these formulas. So delta E is equals to m capital R square omega square Cs. R is the radius, omega is the angular velocity, Cs is the coefficient of fluctuation of speed. So linear velocity v is equals to r omega. So replacing capital R omega with v, so the formula becomes mv square Cs. So depending upon the problem given, we need to use the relevant formula. So here you can see the another formula for delta E, pi square by 900 mk square n into n1 minus n2, and pi square by 900 mk square n square Cs. So please remember all these formulas. So since this unit is very easy and it is entirely formula based, so there will be around 10 to 15 formulas which you need to remember. So coming to the problems. So the mass of the flywheel of an engine is 6.5 tons. Radius of gyration is given 1.8 meters. So turning moment diagram, that the fluctuation of energy is 56 kilonewton meter. So the fluctuation of energy is represented with delta E. So it is given as 56 kilonewton meter. So the mean speed of the engine is given as 120 rpm. So the mean speed is nothing but capital N. So he asked you to calculate the maximum and minimum speeds. So as I have already shown you the different formulas for delta E. So here we need to use the formula delta E is equals to pi square by 900 mk square n into n1 minus n2. Why? Because he has given the values of k, capital N. So we will use that particular formula. So here the value of mass of flywheel is given as 6.5 tons. So by converting it into kgs, we will be getting 6500 kgs. And radius of gyration is denoted with small k. Delta E fluctuation of energy is given as 56 kilonewton meter. So speed, mean speed is given as 120 rpm. So we will substitute all those values. So delta E is equals to pi square by 900 mk square n into n1 minus n2. We are using that particular formula. So delta E value is substituted, 56 kilonewton meter, so 56 into 10 cube, pi square by 900, m mass of the flywheel is 6500, radius of gyration is 1.8, mean speed is given as 120. So we have substituted all those values. So the unknown value is only n1 minus n2 in that particular formula. So we got n1 minus n2 as 2 rpm, and moreover another data with respect to the mean speed of the engine is given as 120 rpm. So mean speed is denoted with capital N, for which the formula is n1 plus n2 by 2. So n is equals to n1 plus n2 by 2 is equals to 120. By that we have calculated n1 plus n2 value as 240. So we have two equations, n1 plus n2 and n1 minus n2. By solving those two equations, we will be getting the values of n1 and n2 which he has asked you. So he has asked the values of maximum and minimum speeds, which we have obtained as 121 rpm and 119 rpm. So hope you understood this problem. So I will explain you the remaining models in the next presentation. So thank you.